Number 43, a force of 5 newtons acts on a 15 kilogram body initially at rest. Compute the work done by the force in letter A, the first, the second, and the third seconds, and letter D, the instantaneous power due to the force at the end of the third second. Okay, so the work, the relation between the work and the power is equal to the integral between the first instant and the second instant of the power times dt, right? And the power can be written as the force times the velocity. So this is t1, t2, f times v times dt. The force we have here is 5 newtons, but the velocity we do not have. However, we know that the force is constant, and if the force is constant, so is the acceleration. And when the acceleration is constant, there are three different equations that we can use. X equals to x0 plus VOT plus AT squared over 2. We can also use V squared equals to VO squared plus 2 times A delta X, and V equal to VO plus AT, right? So since the initial velocity is 0, we can send this away. So V is equal to A times T. And from Newton's second law, we know the F is equal to mass times acceleration. So acceleration is equal to F over M. So we can just replace this over here. And then we find that V is equal to F times T over M. And now we can just send this at that point, and then we can try to calculate the work done. So the work would be the integral from T1 to T2 F times Ft over M dt. So this is equal to the integral from T1 to T2 F squared T over M dt, and this is just F squared T squared divided by 2M from T1 to T2. So we can use this equation over here to find the work for letter A, B, and C. That's what we are using here. So for letter A, the work will be F squared T squared over 2M from 0 to 1. So this is equal to F squared times 1 squared over 2M, and this is 5 squared times 1 over 2 times 30, and this gives us, let's see, 0.83 joules. So that's the answer of letter A. For letter B, it's the same thing. So it's going to be F squared times 2 squared divided by 2M. And this gives us 2.5 joules. For letter C, again, the same strategy. So the answer is going to be 4.2 joules. So that's the answer for letter A, B, and C. For letter D, we want the power, and we know that this over here is equal to this over here, and for instance is this, right? So the power is equal to F squared T over M, and we want to know the power at the end of the third second. So T equals to 3. So the power at that instant would be equal to 5 squared times 3 over the mass, which is 15. So this is equal to 5 watts. And that's it.